Now we're going to look at the general equation of a line so that you can always recognize a line when you see it. And there are a couple of formats of the equation. If the line is not vertical, then it must have a y-intercept. So if a line is not parallel to the y-axis, then it has to cut the x-axis at some point. And let's call that point B. And to be precise, the full coordinates of that, the x is 0 and the y is b. So this line has slope m, say, and it cuts the y-axis at 0b. And so therefore, according to our information above, the equation of the line is, this is x1, y1. The equation of the line is given by y minus y1 equals mx minus x1. But here x1 is b, x1 is 0, and y1 is b. So we have y minus b equals m times x minus 0, and that means that the equation of the line looks like this: y equals mx plus b. And this is called the slope-intercept form of the equation, because if I see an equation in this form, and I know it's the equation of a line, I can identify the slope immediately. It's the coefficient of x, as long as the y is on one side and everything else is on the other side. And the y-intercept is at b, or at 0b to be more precise. Now conversely, suppose I have an equation that's of this form, say y equals 2x plus 1. Is that the equation of a line? And yes, it is. That's the equation of the line that runs through 0, 1 with slope m equals 2. And how do I know that? Because if I actually figure out the equation of this line, it's y minus 1 equals 2 times x minus 0, I get this equation. So any equation that looks like this is the equation of a line, and any line which is not parallel to the y-axis, which is not vertical, has an equation that looks like this. So lots of lines have an equation that looks like this, and anytime you see an equation that looks like this, you know its graph is a line. Suppose I know that a particular line runs through the y-axis y equals 3 and has slope negative 2, then I can write down its equation immediately. Y equals mx plus b, where b is the y-intercept. Y equals negative 2x plus 3 is its equation. So if I'm given this much information about a line, I can write down its equation right off the bat. Now, to be more precise, we have to allow for situations where lines are vertical, and this general equation of a line also captures those lines. And in addition to that, it captures the previous lines, the previous set of lines, where y equals mx plus b. So the general equation of a line is given by ax plus by equals c, where a, b, and c are constants, quite possibly equal to 0. Every equation of this form, if b is not equal to 0, then this is certainly a line, because I can divide across by b, and I get a over bx plus y equals c over b is an equivalent equation describing the same graph, and this is just of the form y equals negative a over b x plus c over b. So this is in slope-intercept form. This is an mx plus b line, and this is certainly the equation of a line in slope-intercept form. Every non-vertical line has an equation of the form y equals mx plus b. So this is a degenerate form of this general equation. This is an equation of the form ax plus by equals c if I set b equal to 1, which is the coefficient of y. And if I set a equals negative m, so that when I bring it over here, I get negative mx plus y equals this lowercase b, which I can take as c here. So every non-vertical line looks like this. Everything that looks like this with b not equal to 0 is a line, and every non-vertical line has an equation that looks like this. What about vertical lines? Well, if a line is vertical, then all of the x values are the same on the line. So for a vertical line, it's got some x-intercept, let's call it d, it's my origin, and a vertical line contains all of the points above and below d. So it contains all of the points whose x values are d, and so it's exactly the graph of the equation x equals d. So this fits into the general equation of a line. We have x equals here, if we let d equal capital C here, and let a equal 1 and b equal 0, we see that this is a degenerate form of the general equation of the line. So every line has an equation of this form, and every equation of this form with b not equals to 0 is certainly a line. What if b equals 0? Then the line looks like ax equals c, and it's of this form, so it's a vertical line. So every line looks like this, and everything that looks like this describes a line. And so this is our general equation of a line. Now it's good to remember what the equation of a vertical line looks like. It's just x equals some particular value of x, and it includes all of the points with that x value. If a line is horizontal, then its y value is fixed. For example, here's a line running through a horizontal line running through the y value 8, and so every point on this line, the y value is 8, and so therefore, vice versa, every point where the y value equals 8 is also on this line, so it's the graph of the equation y equals 8. Similarly, for this line, we have, it cuts the x-axis at -5, and it's got all of the points in the plane whose x-coordinate is -5, so therefore it's the graph of the equation x equals -5. Now it's good to remember that equations of this form give us horizontal lines, and equations of this form give us vertical lines. Suppose I'm given an equation of a line, how do I sketch it? Well, again, as I said, it's good to remember that something of the form y equals 5 is a horizontal line, and it's just all of the points in the plane where the y values are 5. So it's just a horizontal line running through the point 5 on the y-axis, and something that looks like x equals d is just a vertical line, and this one is x equals -3, so its graph is just all of the points running through on the line, the vertical line running through -3 on the x-axis. That one's the graph of y equals 5. Pardon me. So we have the vertical line through x equals -3, the horizontal line through y equals 5. What about something of this form? How do I graph it? Well, the easiest way is to find 2 points, get some straight edge, join the 2 points, and extend. And the easy points to get are the intercepts. And those intercepts happen, the x-intercept happens at the point where y equals 0, and that happens for this line when 8x equals 10, or x equals 10 over 8. So the point 10 over 8, 0 is on the line. And now to get another point, I take the y-intercept. That happens at x equals 0. That happens when 2y equals 10 or y equals 5. So a graph of this line looks like this. It cuts the y-axis at 5, the x-axis at 10 over 8, which is about here. And that gives me 2 points, and then I use a straight edge to join those. And then I extend that straight line, and that's a graph of my line. For this one, I can find the x-intercept. That happens when y equals 0, and that's when 5x equals 30, or x equals 6. So that cuts the x-axis at 6, and the y-intercept happens when x is 0, and that happens when y is 30. So this one cuts the x-axis here, and I'm going to change the scale for the y-axis because 30 is a relatively large number. That gives me 2 points on the line. Now I join those with a straight edge, and I get a perfectly straight line through them, which goes on to infinity and beyond. Now, if it turned out there was just one intercept at, say, 0, 0, then to find another point on the line, I just plug in any value of x and calculate the corresponding y value to get a point.